Hello students, welcome back to the section on measures of dispersion. In this section, part 2 of measures of dispersion, I am going to discuss myself, Dr. N.V. Ravi, I am mentor for this section. Hello students, in the earlier session we had discussed about the range and mean deviation. Though mean deviation is an improvement over the range so far as measures of dispersion is concerned. Mean deviation is difficult to compute, and furthermore it cannot be treated mathematically because all the absolute values, that is negative values, also treated as positive values, but mathematically it is absurd. So the best measure of dispersion is usually standard deviation, which does not possess the demerits of range and mean deviation. Standard deviation for a given set of observations is defined as the root mean square deviation. Simply, students has to remember the simple form of the standard deviation is root mean square deviation. This is the simplest form of the definition. Now I have to define the standard deviation for the sample data x equal to and square root of summation of xi minus x bar whole square by n. This is the for a standard deviation for the ungrouped data for individual series, and this is the individual series. In case of standard deviation for the grouped frequency distribution, the standard deviation can be written as summation of fi xi minus x bar whole square by n, where n is sum of the frequencies. Now this can be written in the simple format as follows: s equal to square root of summation of xi square by n minus x bar whole square, and further this can be written in the simple format summation of fi xi square by n capital N, this is capital N, minus x bar whole square. This is for the grouped frequency distribution. Now from this we can find this is the square root of the standard value, root mean square from the deviation. Now square of the standard deviation value we called as another important concept, which is very important here, is variance. Variance is the square of the standard deviation, and it is also measures the dispersion. Actually, variance is equal to s square, and it is the summation of xi minus x bar whole square by n for unclassified data or individual series. This is the individual series. In case of ungrouped the grouped classification without square, that is summation of fi xi square by n minus x bar square. This is the for grouped data. Now we have to come to the other importance, which is relative measure of dispersion in the standard deviation is given by is called the coefficient of variation. One of the important tool in statistics is the coefficient of variation. With the help of the coefficient of variation data, this how much percentage of varying from the mean it will help us actually. then CV equal to standard deviation by mean into 100. If we want to compare the efficiency of the or the consistency of the two batsmen in cricket match, then we used to find the coefficient of variation between two batsmen. Lesser the covariation data, the more the consistency in their performance. We can conclude like that. Now coming to the important properties of standard deviation. For any two numbers A and B, standard deviation can be computed as modulus of A minus B by 2. This is the very important formula, and S equal to this one. And the absolute sign is taken, SD cannot be negative. And now coming to the important properties related to standard deviations. Let's see one by one. If all the observations assumed to be a variable constant k, then SD is 0. That means that all values are taken by variable k is constant, then S is 0. The result applies to range as well as mean deviation. One of the important property for the examination point of view also, if all the observations assumed to be variable constant same number SD, then SD is assumed to be, standard deviation is assumed to be 0. In the case of range also it is 0. In the case of mean deviation also this is the same condition. This is the important property. SD remains unaffected due to change of origin, but is affected due to same ratio due to change in scale. Suppose two variables x and y related to y equal to a plus bx. For any two numbers constants a and b, here a and b are two constants, then SD of y is given by modulus of b times standard deviation of x. This property is applied in the case of mean deviation, range, standard deviation, as well as in the further we have to discuss in the quartile deviation also. What I want to say here, A is called the origin, B is called the scale. That means whether the variables whether increase or decrease in some proportion, then the standard deviation, mean deviation, quartile deviation, range will not affect. Whereas if it is in the some ratios like proportion increase like B, that means either multiplied or division, then in that case it will be increase in this product of b times of standard deviation of x value. This is very important formula for the case of the linear equation y equal to a plus bx. Next one, if there are two groups containing n1 and n2 observations, x1 bar, x2 bar respectively. Here suppose we have two groups containing respectively n1 and s2, n1 group and n2, respective standard deviations are also s1 and s2, and now we have to find out the combined standard deviation for this formula. That is s equal to square root of n1 s1 square plus n2 s2 square n1 d1 square plus n2 d2 square divided by n1 plus n2, where d1 equal to x1 bar by x bar, d2 equal to x2 bar minus x bar, where x bar equal to combined arithmetic mean, that is n1 x1 bar plus n2 x2 bar by n1 plus n2. And This is the very important formula for using for the combined standard deviation when the two observations n1 and n2 are then respective standard deviations are s1 s2 and that are n1 s1 square square root of n1 s1 square plus n2 s2 square plus n1 d1 square plus n2 d2 square by n1 plus n2 where d1 equal to x1 bar minus x bar, d2 equal to x2 bar minus x bar, where x bar is n1 x1 bar plus n2 x2 bar by n1 plus s2, which is combined combined AM. This is combined arithmetic, combined standard deviation. This is combined arithmetic mean. Now, further continuation of the property of the standard deviation. Here we are not. I'm not going to prove the property of the standard sum of the standard deviation of first n natural numbers. Just remember the examination point of view. The standard deviation for the first n natural numbers is square root of n square minus 1 by 12. Suppose if we want to find the standard deviation of the 7 first n natural numbers 1, 2, 3, 4, 5, 6, 7. That is 7 square minus 1 by 12. That is 49 minus 1 by 12. Square root of 48 by 12. That is 4. Square root of 4 is the 2. So standard deviation of first 7 natural numbers is 2. Question number 1. Find the standard deviation and the coefficient of variation for the following numbers 5, 8, 9, 2, 6. Before computing the coefficient of variation and standard deviation, we should know the formulas for this. Thus, the standard deviation is equal to summation of square root of summation of xi whole square by n minus x bar whole square. And the CV coefficient of variation equal to standard deviation by arithmetic mean into 100. These two formulas just very important here. Just look at how we are applying these formulas. In this, before computing this, here the summation of xi square, that each observation, this 5 square is 25, 8 square is 64, 9 square 81, 2 square 4 and 6 square 36. If you sum up this 25 plus 64 plus 81 plus 4 plus 36, this will equal to 210, and sum up of 5 plus 8 plus 9 plus 2 plus 6 is 30, and x bar equal to summation of x by n, that is 30 by 5. 30 by 5 is 6, so mean is 6 here, and then standard deviation equal to square root of 210 by observations here is 5 and mean is 6 whole square, which is 42 minus 36, which is equal to square root of 6, which is 2.45. And further, the coefficient of variation CV equal to standard deviation is 2.545, mean is 6 into 100, which is equal to 40.83%. Question number 2. Find the SD standard deviation of the following distribution. Here weights in kgs are given and number of students. 52, 58, 17, 52, 54, 35, 54 to 56, 28, 56 to 58, 15, 58 to 55. And if we sum up this is the 100 total. Now we are going to compute this SD of standard deviation for this given data with the help of this deviation method. Let us look at the formula here. Fi summation of Fi di square by n minus summation of Fi di by capital N whole square into class interval C, length of class interval. In the next slide, we can compute this formulae. How? Let us look at in the next slide. Now, in this data, weights in kgs are given. Let's look at the data. Once again, I am writing here 50 to 52, 50 to 54, and 54, 56, 56, 58, 58 to 60, and in this column we are going to compute the totals. And number of students are 17, 35, 28, 15, 5. Sum of this is 100. Now we have to compute the mid values. This is lower boundary, this is upper boundary. Then sum of these 2 by 2, 50 plus 52, 100 by 2, that is 51 is the mid value here. And this one here, the length of class interval is 2. The difference between two upper lower boundaries or two lower boundaries are upper boundary minus lower boundary is 2. Then if you add these two, 53, then 55, then 57, 59. Now we have to take the formula di values. Di equal to xi, each mid values are represented as xi values, and number of students are represented as frequency x values, fi values, and di equal to xi minus, we have to assume some mean value. Here the a is assumed mean, that a is here by c, length of class interval. Now we are assuming that a is 55 here, and 55 minus 55 is 0, 0 by 2, 0. 53 minus 55 minus 2, minus 2 by minus 2 by 2, minus 1, and it is 51 minus 55 minus 4 by 2, it is minus 2. Now the upper value, these values are negative increasing, these values are positive. Now this is plus 1, this is plus 2. Now we have to find out the Fi di values. This is 17 into minus 2, minus 34, and this is minus 35, and 28, 0, 15, and 30. Now this di square is also important. That di square is minus 2 square 4, 4 into 17 4s 68, and minus 1 square plus 1 35, and 28 into 0 square 0, so this is 0, and 15 into 1 square 15, and 5 into 4 20, and sum up of all these observation 138. This plus and minus get minus value is higher side, minus 44. We all know already the formula SD is using the deviation method, summation of Fi di square by n minus summation of Fi di by n whole square into C. Look at what are the values here. We have found 138 by 100 minus of minus 44 by 100 whole square. Here length of class interval is 2, so this will be 1.38 minus 0.1936 into 2, which is equal to 2.18 kgs is the standard deviation of this data. Question number 3. If AM and coefficient of variation of X are 10 and 40 respectively, what is the variance of 15 minus 2X? Now we have to compute the value of the variance of 15 minus 2X. Let here y equal to 15 minus 2X, and here standard deviation of y equal to this modulus of minus 2, that is 2 of standard deviation of x. As given here, the CV of x, coefficient of variation of x is 40 and x bar equal to 10, and CV of x is formula CV of x equal to standard deviation of x by x bar into 100. Now, which is 40 equal to standard deviation of x, we have to find out, by mean of x is 10. So it implies from this standard deviation of x equal to 4. When standard deviation of x is 4, using this, here we substitute this, standard deviation of y is 2 times standard deviation of x, that is 2 times 4, that is 8. You know, variance of 15 minus 2x whole square equal to, this is the standard deviation of this variance of y for this function. Standard deviation of the for this function. Now for that, variance is square of this value, that is 8, variance of y is the square of this value, so 8 square, ultimately 64 is the variance of 15 minus 2x whole square is 64. Question number 4. Compute the SD of 95862. Without any more computation, obtain the SD of sample 1, sample 2, sample 3. In sample 1 data, if you look at this data is some linear form actually. -1, -5, -2, -4, -8, and second sample also some linearity equation form, and third equation is also some linear equation form. Now, first we have to look at how to compute this data. This equation is in the form of y equal to -10 plus x, and second sample is in the form of y equal to 10x, and third sample is of the form y equal to 5 plus 2x. If you assume these values are x, and this sample 1, sample 2, sample 3 equations are of the form y equal to -10 plus x, -10 plus x, and y equal to 10x, y equal to 5 plus 2x, 3 sample format. You know, when x values are this format, first we have to find out the x standard deviation. Based on that, these values standard deviation also we can compute. Now look at the sample 95862. For this data, the standard deviation s equal to summation of xi square by n minus x bar whole square. This, if you sum up the square, this is the 81, 25, 64, 36, 4, this is equal to 210, and sum of these values is 30, and this is equal to, substituting these values here, 210 by 5 minus 30 by 5 whole square, which is equal to square 42 minus 36, which is equal to square root of 6, which is equal to 2.45. Now, using the earlier slide, the first sample is y equal to -10 plus x, and We have to find the sample standard deviation for this data. Sy equal to this value is 1 here, coefficient is 1 times of standard deviation of x. In the earlier slide, we have computed the standard deviation is 2.5, 1 into 2.545, which is equal to 2.45. In case of this is the applicable for the data of sample 1, and for the sample 2, the relation between y and x is y equal to 10x. This is the sample 2. That is, the standard deviation of y is this coefficient 10 times into standard deviation of x. Standard deviation of x is 2.45, 10 into 2.45, which is 24.50 for the sample 2. Now, lastly, for the sample 3, we have to compute the standard deviation. Y equal to the equation of the form 5 plus 2x. The standard deviation of y is, this is the scale here. The scale factor only affects here, so the scale is 2 here. 2 into x and 2 into standard deviation of x is 2.45, that is 4.90. So for the third equation, third sample, the standard deviation is 4.90. Question 5. For a group of 60 boys, the mean and ST of stat marks are 45 and 2 respectively. Here mean and SDR, mean is 45 and SD is 2. The same figures for a group of 40 girl students are 55 and 3 respectively. What is the mean and standard deviation of the two groups of the fold together? Now, before computing this, here the first one group is the N1 is 60, X1 bar is 45, S1, that standard deviation is 2, and N2 is second group for girls is 40, and their mean is X2 bar is 55, and S3, S2 is 3. Now we have to compute the combined mean and combined standard deviation. In the next slide, we compute the combined standard deviation and combined mean. Let us look at the combined mean formula. X bar equal to N1 X1 plus N2 X2 by N1 plus N2, which is equal to 60 into 45 minus plus 40 into 55 by 60 plus 40, which is equal to 49, which is the combined average of girls and boys students. Now we have to find the combined standard deviation also. Before that, we need the value of D1 values. D1 equal to X1 bar minus X bar and D2 equal to X2 bar minus combined X bar. Here D1 value is computed, and that is 45 minus 49, which is 55 minus 49, which is minus 4, which is 6. X1 bar is 45 already given in the earlier, and X2 bar also given as 55. The combined mean we have found. After subtracting this, minus 4 and minus and plus 6 are D1 and D2 value. Now let us look at the value of combined standard deviation value. That is n1 s1 square plus n2 s2 square plus n1 d1 square plus n2 d2 square whole divided by n1 plus n2, which is equal to square root of 60 into 2 square plus 40 into 3 square plus 60 into minus 4 whole square plus 40 into 6 square. These are d2 squares whole divided by n1 plus n2 is 60 plus 40. Now this simplifying after that, this will be equal to 30. Square root of 30 is 5.48. This is the combined standard deviation for boys and girls in a class. The mean and standard deviation of the salaries of the two factories are provided below. Here, two factories are A and factory B. And number of employees for factory A is 30 and mean salary is rupees 4,800 and SD of salary is rupees 10. Now we can say that this is N1, this is the X1 bar and this is the standard deviation of 1. On factory B, this is the number of employees is N2 here, that is the 20, and rupees 5,000 is the mean salary, that is X2 bar, and SD of salary is S2. Find the combined mean salary and standard deviation of salary. Now using the earlier slides also, just you can reveal this earlier where combined mean and combined standard deviation also computed. That formulas first we can apply. Next, second question is examine which factory has more consistent structure so far as satisfying the employees are concerned in terms of salary. Now CV equal to, first comparing the two data separately, the CV of factory A and the CV of factory B also, and that is the standard deviation by mean onto 100, mean into 100 for factory A separately and factory B also separately. Then whichever is less, that data is consistent, we can say that. Now let us see in the next slide how we can compute the data for that. Now let us look at the computation of the combined mean and combined standard deviation. Before that, what are the data are given? Let us look at once again. N1 equal to 30, X1 bar equal to rupees 4,800, S1 equal to rupees 10, and N2 equal to 20, X2 bar equal to rupees 5,000 and S2 equal to rupees 12. Now the combined mean equal to X bar equal to N1 X1 plus N2 X2 by N1 plus N2, which is equal to 30 into 4,800 plus 20 into 5,000 whole divided by 30 plus 20, which is equal to rupees 4880. Now D1 equal to X1 bar minus X bar, which is 4880 minus 40, which is 4800 minus 4800 minus 4880, which is rupees minus 80. This is in terms of this minus rupees value 80 value, and D2 is X2 bar minus X bar, which is rupees 5,000 minus 4880, which is rupees 120, and combined standard deviation S equal to square root of N1 S1 square plus N2 S2 square plus N1 D1 square plus N2 D2 square. Then 30 into 10 square plus 20 into 12 square plus 30 into minus 80 square plus 20 into 120 whole square whole divided by 30 plus 20, which is equal to square root of 9717.6 and which is equal to 98.58, which is the combined standard deviation of this data. In the earliest slide, we have computed the combined mean and combined standard deviation. Combined mean is rupees 4880 and combined standard deviation is 98.58. Now, second part of this question, we have to compute the consistency of the structure in the salary between two factories A and B. Now, before that, we have to compute the coefficient of variation of factory A, that is standard deviation of factory A by mean of the factory A, x bar f factory A into 100, and coefficient of variation of the factory B, that is the standard deviation of factory B by mean of the factory B into 100. Now, look at which is the more consistent. Now, in the case of factory A, this is the 10 by 100, 10 by 4800, 10 by 4800 into 100, which is equal to 0.21 is the CV of factory A. In the case of factory B, let us look at the data. Based on that, the standard deviation is 12 and standard mean of that data is 5000, and 5000 into 100, which is equal to 0.24. And if we compare these two data separately, two factories data A and B, let us look at the covariance and the variance between these two data. This is 0.21, this is 0.24. So smaller one is the more consistent, so factory A is the more consistent, we can say. Now coming to the question, a student computes the arithmetic mean and ST for 100 observations as 50 and 5 respectively. Later on, he discovers that he has made a mistake in taking one observation as 60 instead of 50. What would be the correct mean of and SD if the wrong observations is left out? And second one, if the wrong observation is replaced by the corrected observation. Now we have to compute the when the observations is left, wrong observation is left, and in the place of wrong observation is replaced by the correct observation, also we have to compute. Now, as for the data given here, the n equal to 100 and x bar is 50, standard deviation is 5. Wrong observation is equal to 60. The wrong observation is 60 and the correct observation is 50. Now, x bar equal to summation of xi by n. From this, summation of xi equal to n into x bar, which is equal to 100 into 50, which is 5000. Now, and s bar equal to summation of xi square by n minus x bar whole square, and from this summation of xi square x is equal to n into x bar square plus s square, which is equal to 100 into 50 square plus 5 square, which is equal to 252 500. Now see, the first question is the wrong observation is left out. Then after that 99 observations. So sum of the 99 observations is 5000 minus 60, which is equal to 49 40. 49 40. And sum of the squares of observations after leaving the wrong observations. And in the case here, that is 500 minus 60 square, which is equal to 248 900. Then variance of 99 observations is sum of the deviation, the squares, that is 248 900 by 99 observation, and respective mean is 49.90 whole square. And after that simplification, which is equal to 24.13. So SD of 99 observations is square root of 24.13. There's SD of 99 observations. This is square root of 24.13 is 4.91 is the SD of 99 observations. Now in the second situation, that is sum of the 100 observations after replacing the wrong observation by the corrected observation as follows. Now sum of the observations is as follows, then which is sum of the observations, originally it is 5000 and minus 60 is wrong one and corrected one is 50. After that replacing that one, 49 90 is the one, and AM of these observations after replacing the corrected one, that 49 90 by 100 observations, which is equal to 49.90 is the AM. Then corrected sum of squares, that is x square is as follows, that is originally it is 2,52,500 and that wrong corrected one is 50 square, wrong one is 60 square, and after replacing that, this is 2,51,400, and corrected SD is formula as follows: 2,51,400 by 100 observations and 49.90 square, which is equal to square root of 45.99, which is equal to 6.78 is the, after replacing the corrected corrected observation, the standard deviation is 6.78.